Perfect. So it's nice to be here. As said, I'm sitting in the sunny Gothenburg, which is actually brilliant to compare what is usually in Finland currently. So we are having like 1 meter snow back in Hyvinkää, close to Helsinki, where I'm usually living. But I will spend a few months still in here, Gothenburg, hopefully enjoying this excellent weather. But for today's lunch, I was going to talk about the software-intensive business ecosystems and how ecosystems are changing software-intensive business. And I was going to use some time to go through two cases, one that we have been studying a bit more, and one that is kind of emerging topic that I was hoping to study more and understand more. But just briefly present myself. So my name is Sami Hyrynsalmi. To be honest, the surname is really complex even in Finland. So my kindergarten teacher wasn't able to pronounce that correctly. So it's completely okay to call me just Sami. So usually most of people will just call me with my first name. As said, I'm working for the Lappeenranta-Lahti University of Technology LUT. So we are just using the LUT, but we are a rather small new university in Finland working on 2 domains on technology and business. And as the name hints, we are having 2 campuses, one in Lappeenranta, quite close to Russian border, and one in Lahti, like 100 kilometers north from Helsinki, so still close to the capital city area. I have been now working for LUT University for almost 3 years. Previously, I was working for Tampere University, Turku University, Technology and School of Economics and so on. But what has always been fascinating me is the software and how to make money with software. So kind of driving slogan that I have been using in my research career is this: how to make money with software and how to bridge the gap between engineering activities and business development activities in software companies. And I have special interest on the new emerging technologies and the revenue and business model caused or enabled by those new innovations. As said, LUT is a rather small university, but we are focusing on technology and business and quite much on sustainable development. We are having around 6,500 members, including students, staff members, and so on, who are working in these 2 campuses. And I'm personally working at the Lahti campus. Something that is worth to mention about LUT is that we are also doing quite a lot of collaboration between the companies and other parties in Finland. So around half of the funding that our university is getting is coming from the different kind of supplementary sources like organizations, EU, research funding organizations, and so on. So we're trying to do quite close collaboration with the industry in Finland, as well as abroad too. But slowly move into the topic of today. So ecosystems and software-intensive business, and how ecosystems has been able to change the world in software.
Okej, men du låt mig läsa igenom det där så att jag är lyssnarkontrollörande.
Someone seems to have still their microphone open, but hopefully that's not disturbing too much. A year ago, we had a discussion with most of the professors in Finland, and we did a survey. What are the trends of software industry and what will be the main driving forces that will shape the software industry in the future? And I'm quite sure that most of you have already seen how the ecosystems are having their impact on software industry, but also there will be lots, or not maybe lots, but there will be still changes caused by the platforms and the ecosystem and a so-called ecosystemization process, where almost everything is moved toward ecosystem kind of working, where, as put by Ian Levien, loose networks of people and different kinds of organizations are putting their powers together so that they will be much more powerful together than they would be individually. And then these kind of ecosystems are fighting against each other for the market share and business. While the ecosystem paradigm and this kind of ecosystem thinking has been present almost for 20 years or even a bit more, there are still lots of uncertainties and unknown things that haven't been addressed that well in software or even the business ecosystem field. And I was going to plan to spend some time on explaining what we have been done in one of the area, so-called ecosystem health research. Sorry for that. So ecosystem health is quite, let's say, well-known concept in the academic scholars. So it's basically trying to characterize how well different organizations and how well overall the ecosystem is doing. It's kind of similar than we can consider about the well-being of individual people. So what would be my health as a young, well, not young anymore, but as a male Finnish citizen, and what it would mean? I'm doing well, I'm sick, are there some problems that need treatments, and so on. So it's kind of similar concept that we can think about the overall health or well-being in any individual person or any individual organization even. The kind of driving force to understand ecosystem health is that Iosten Levien stated almost 20 years ago that single company's success doesn't anymore depend on their own powers and on their own well-being, but on the collective health of the organization, this ecosystem that is working beneath of them. And therefore, we should understand the ecosystem health and we should try somehow to improve it and note if there is some problems and if we can treat them with some kind of targeted medicine as well as we can. This kind of ecosystem health thinking would be, or metrics, how to assess it and identify would be useful for different kinds of companies and different kinds of peoples. Of course, for the orchestrator who are running the ecosystem, who are kind of responsible for the ecosystem to move forward, as well as the individual companies and individual actors inside the ecosystems, because that kind of measures would help them to identify what are good or surviving ecosystems where to join and what are tools that might not be that good places to jump in. And as a concrete example, around 10 years ago, we can think about the competition between Windows mobile phone, Google Play ecosystem, as well as Apple App Store. So there, when companies were thinking that which of these is going to be the one that is worth of investing, these kind of measures would be able to help them to make the decision where to go. And of course, the third group would be all the externals of the ecosystem, like market analysts or even governmental officers who are trying to analyze the ecosystem and its potential. As said, the ecosystem health model has been present for some time, and there is one classic model that is kind of rolling. I have seen at least a dozen different kinds of models that how to measure and how to define what is the ecosystem health, but more or less all of them are relating to this one, or they are inheriting some features of this classical model by Marco Jensity and Levien from 2004. They defined that there are three main characteristics or dimensions that should be measured when we're trying to understand the overall health of an ecosystem. And they are the productivity, kind of basic, how the network is able to turn new innovations and new thinking, new potential, what are available as a lower cost, as a new innovative product, and as a new revenue. Robustness, we try to somehow capture how well the ecosystem is able to take and absorb external shocks. And this kind of a classical example that I'm going to bit more discuss later is that how, for example, SYMBIAN was able to absorb the shock caused by iPhone in 2007 when the new technology of the smartphone as well as the App Store were introduced. And I think it's kind of easy to say now, a bit more than 15 years later, that SYMBIAN didn't do well. So they weren't able to take the shock caused by this new innovation. So their robustness in that sense was quite low. And the third dimension in this model is the niche creation. So how the companies are able to invent new and create a new products, new innovative offering in the ecosystems, and so renew the ecosystem by itself. But as said, there is some problems also in the model. And I'm going back to the case of SYMBIAN. As said, I'm from Finland, and this is quite close to my heart. So I have spent some time to understand what happened in SYMBIAN, and would this kind of ecosystem measurement be able to help the companies at that point trying to assess and perhaps even to react somehow into the shock caused by the iPhone. And if we take a look on the classical measures used by or kind of recommended by the Levian, it's actually to look at that everything was doing well. SYMBIAN was stable, the measures were stable, they were a bit growing, not too much, but kind of everything looked good. But as said, it's easy to be wise after the event. There were huge problems, but these metrics proposed by Ernst and Levin weren't able to note those, and they were able to predict that. And what makes it even more problematic is the case that almost all of the market analysts were able to say months or even year before, when the metrics started to turn down, that SYMBIAN is in trouble and I wouldn't be anymore investing on that one. So in this case, in the end, we were in a situation where someone's personal opinion and kind of personal experience had more value than the metrics that had been developed by the scientists. And that's kind of the problem, what the starting point for these research activities. So what's the actual value of ecosystem health models and metrics if they are not able to predict that well in the future? So together with my colleagues, we tried to do kind of new starting for ecosystem health, and we've completely dropped out from the last work that has been done, this productivity, robustness, and integration aspects. And we were, after some planning and research, we ended up recommending these two different characteristics that might be able to tell a bit more beforehand that there will be some problems. At this point, I wish to emphasize that this is still research in progress, so we haven't been able yet to prove an empirical evidence for this one. We are trying to collect some old data, and so with the case of SYMBIAN, that would our model be a better to predict the things that, for example, University of Turku were. So this is still kind of forthcoming things, and it's completely possible that we are going to, or this won't work. So that's the science. So might be that we need to refine also this research at some point. But we are building on the top of two different characteristics that are vitality and longevity. Vitality is a concept borrowed from the field of urban planning, and basically it tries to capture what is the liveliness of certain area or certain economic block and how well it's living. So it's kind of a pulse. So is there some kind of pulse still going on, and how fast that pulse is in the certain domain? And longevity is again a concept borrowed from the field of demography, and it's trying to somehow capture what is the life expectancy of a people, and in our cases, the companies as well as the ecosystem. And that's why it's quite hard to forecast what is the day of someone's death when something will happen. But instead, it's a bit easier to put people as well as population in kind of order based on some characteristics like smokers versus marathons. And they are, at least in the field of demography, they're arguing that it's likely that smokers are not going to survive as long as the marathoners. But as always, this is statistics, and there can be some outliers in the model. But when these two different characteristics are put together, we get this kind of double dichotomy, which somehow tries to character where the ecosystems are, and would there be some kind of need to do some actions for the ecosystem and try to perhaps improve the situation. And we are here calling the three different blocks as unstables, which means that the vitality is high. It is likely a new ecosystem that is emerging or has entered the market, but its longevity is yet not clear. Basically, the measures used are not saying too much, so this can be moving in any other trio of blocks, and is also as likely as that it will become a superstar, that it will die out. The block here that is the most unwanted is the zombie category that we are calling as the living deaths. And there the vitality is low and the longevity is low. So basically everything seems to be solving in the direction that these ecosystems are going to die out. I'm here using two examples that are already a bit outdated. So BlackBerry World was finally closed in January 2022, I think. So even though I think it has been for all market analysts and almost everyone quite clear for even a decade that it won't survive, it was still there. Everyone was just waiting that it will eventually die out. Then there is the block of niche solutions. For example, some open source projects seems to be that there is no actual polls being on, but the longevity measures are showing that there is not that many changes going on, so it's quite likely that it won't die out, but it's kind of a present, not doing that well, but it will survive. And then, of course, the final group that are the superstar, that longevity seems good and vitality is good, so they are surviving, at least currently, and they are doing quite well. So just kind of close this part of the presentation. There are lots of different metrics proposed for the ecosystem health evaluation, and some of them are really complex. And even though I do not have any scientific evidence to say that some measure is better than the other, it seems, at least in my experience, that the kind of simplicity eats complex and sophisticated models as a breakfast. So quite often more simpler methods or metrics seem to work better than those highly sophisticated models that are developed based on the data and that are predicting some aspect, but perhaps not the whole picture of the case. And then moving toward another topic, this is something that I'm currently starting to address and trying to understand, and we are here labeling the data ecosystems, and this is a topic that I'm working with Jan and Helena right now. So there seems to be lots and lots of data collected by different companies, but at least academic research reports still report quite often that companies are having problems of capturing value out of the data. So we're collecting lots of data, but not being able to do that much business out of it. And there is not that perhaps emerging, but at least some kind of new idea that we should put the data in the ecosystem, invite external parties, open it so that we would have so-called open data ecosystem where other parties would be able to use the data that is provided, and the one who is running the platform would get something out of it, as well as the one who has been collecting the data and is providing that for the ecosystem. If you take a look on the academic literature, what is saying about this phenomenon is that there are some benefits that might be good, but there is also some problems. So I'm going to briefly present the benefits as well as the problems, and then close with the kind of call that what are my hopes on this domain. So the thing that is most interesting for me in this research or this area is that this kind of open data would be able to create some kind of open innovation domain where completely new innovative companies would be able to enter, use the data and create something that is not in the domain of the original place where the data has been collected, but for example, something completely different. As an example, I've been using this kind of small, simple things that we did almost 5 or 6 years ago in Finland. We had a discussion with the energy company that they're having lots of data and could be possible that we combine their energy consumption data with the overall weather data and as the public building information data and put that all together. So we'd be able to kind of tell for a certain house that how well you are doing regarding the energy consumption compared to other buildings that are built on the same time, on the same area, having the same kind of weather circumstances and so on. So kind of trying to sell better insulation for those kind of houses. This starting was quickly shut down because we were discussing with the company's lawyer and they said this is completely illegal. We can't use the custom rate in that way. But just an example that how something completely new and novel outside from the original domain could be perhaps being built with this kind of open innovation based open data movement. And what would be also beneficial in this kind of activities that we would be using the ecosystem simulation methods that are, stimulation methods that are quite well known in other ecosystem domains. For example, Windows Phone was quite famous for that they were running a series of different hackathons all over the world and trying to get new applications for their platforms and new ideas. They were paying for students to develop a new innovative solutions, and they were giving prizes for two that are the best ideas for their new platform. Unfortunately, it didn't lie, and there were some kind of in the end, there were lots of work done, but it didn't move that much forward in the Windows Phone ecosystem. And of course, selling data would be able to create a new supplementary revenue stream for the companies. But also the problems here are quite severe, and one of the kind of most demanding problem is the security. And I'm here also using an example from Finland. So there is a company called Polar, which they are selling sport watches that allow you to store and check how well your running is going on. And then they are allowing people to publish some part of that in the social media, showing that, hey, now I was running this marathon and I was doing this well. The problem here was that the Finnish set of white hat hackers were able to hack the system, and they were able to show that there are certain people like military personnel and, for example, airplane pilots that they were identified based on the location where they have been running the non-public marathons and tools like near the military bases. So they were able to show that these are military personnel, and when they combined all the data together, they were able to show that, okay, this airplane fighter pilot is living in this address. And that wasn't thing that Polar was hoping for, and they actually closed down their service quite soon because it was felt that it's so huge security risk for both the individual personnel as well as the Finnish military that we are showing where certain people are living, and we are able to combine the data in different sources so that we know that they are, for example, for this kind of highly educated, highly expensive pilots that would be in some kind of problems if the data would be published. And the other problem that is quite a lot discussed in the literature is data cloning. So the data would be stored in the local server, and then there wouldn't be that much money paid for the revenue of the companies. So this is the setting that we are trying to make some sense. So would be somehow possible to combine the benefits of the data ecosystem thinking while trying to avoid most of the biggest problems related to this domain. And we are, as said, this kind of emerging topic, we are trying to start digging this up, and hopefully we are able to at least tell something about this phenomenon in the future. So that was my presentation. Thank you for your attention, and if you have any questions, I'm happy to answer.